Besides the fundamental academic approach here, we also applied some engineering and empiric tricks as well. Using such techniques, we were able to significantly improve performance, such as on compressors by changing the attack and release states only once in 32 samples, or in IIR performance, where it can now compute 2 output samples at once using 16 independent multiplications. In some critical places for this, we use custom-derived equations to always stay numerically stable and maintain excellent signal-to-noise ratio and a low level of digital artifacts, normally produced by floating-point arithmetic. As mentioned before, we pursued parallel topologies for our effects, and are proud to conclude that all filters in our equalizer implementation, for instance, are parallel and independent. Also, across the board, our data structures like delay line or circular buffer, they're all constructed in such a way that a cost to accessing any element of it has exactly the same cost down to single instruction to prevent any divergency.